Okay, and we are on. Okay, so this is going to be a two-part video. Uh, I guess the previous ones I uploaded are not clear or are not working for some people. So this will be how to properly configure the NRF to communicate between itself or between two units. We are going to be using an HM11 for debugging purposes to display data on the phone, register data, and we have an NRF unit here, NRF unit here. Today we're only going to be doing this one, and we are going to blink the LED, configure HM11, send data to the phone, read and write data to the NRF, and display it on the phone as well. So the HM11 is connected to UART 0 on pin 17 and 16, and the SPI is SPI 1 and is 10, 11, and 12. CSN is on 9 and CE is on 8. So let me change to my setup. So this is my project. It's an empty project. I have a file here to move the data into the Pico, so I don't have to copy and paste all the time. And I have my CMake lists file. So this is what you need to have if you want to have it identical to me, or you can have your own project. This is the project name. I'm going to be using SPI. This is my source file, CMake CPP, and it's in the folder SRC. So let me just close this. So first thing is just have a couple of includes for the Pico and the SPI. We also need the string headers and standard IO. We need a macro. This is a very standard macro you can find online, and this is for converting an integer to characters. So it will take a value, and we are going to check each of the bits to see if they're high, and if they are, then we return a character 1, and if not, then we return a character 0. And we need 8 of this. And we want to check each of the bits. This is 8, 16, and 1 to 8. We also need the main function and a loop. Okay, so that will give us just the regular standard framework to work. And to get started, we are going to blink the LED, the onboard LED on the Pico. So we need to initialize it. That is pin 25. Set it to output. And we'll turn it on. We'll put a delay of 100 milliseconds and then turn it off. 100 milliseconds. So it's going to turn on roughly every 5 times per second, so every 200 milliseconds or so. So let me compile. Let me set this so the data loads. And we are going to see that LED start blinking. Okay. So now onto the UART. So we can send messages to the phone here using the HM11. We said we were going to UART we're going to be using UART 0, and the baud rate is -600. UART in function, and this is going to be pin, we said pin 16 and 17, so 16 and 17. Okay, so that's it. This is what you need to initialize the UART, or at least the minimum. Now we want to send the values to the phone, but we want to convert them to binary. So that's what this macro is for. So we need a couple of helper functions. The first one will be debug, and this one takes a pointer to a buffer. And UART write blocking. We are sending the buffer. We need to calculate the length of the buffer. And it needs to be +1 to account for the 0. And this next character, this is just a requirement for the phone or this application to know that that is the end of the message. It requires a character return. So 1 character, the length is 1, and the next function is gonna be for taking the value, using this macro to convert it to character, put it into a buffer. So this function will return a buffer. Let's call it to bin. It will take a value, the value we're going to convert, and it will take a pointer to a buffer to put the result. So we are going to give it a value, pass a buffer. It's going to take that value, convert it into character using this macro. It's going to put it into this buffer, and it's going to return a pointer to the same buffer. Okay, sounds complicated, but it's really not. So we're going to use sprintf, and this is the buffer, and this we need 8 character holders. That's 4. It's another 4, so we can display the value in binary format. So we're going to put a space in between to make it easier to read. We are also going to display, or I am also going to display the actual value, so it makes more sense. On the left it will show the value, on the right it will show the binary representation of the value. So here's where we use the IC macro, or integer to character, and we pass the value, and that should be it. We return the buffer. So now I can create a buffer and make it of some length, this time 32 characters. I also need a value, and every time it blinks I can send data, so roughly 5 times per second. So I can say debug to binary, pass a value, incrementing as well, pass the buffer, and that should be it. So let me send it to the Pico, compile it. If it works, we are going to start seeing this screen scroll with a value on the left and the same value represented in binary on the right. There you go. Okay, so next thing is to read data or initialize SPI so we can read registers from the NRF. So let's do that. SPI, and we're going to use SPI 1 at 8 megahertz. That's 3 and 4 is too much. There you go. We said it was going to be 10 to 12 for SPI, the pins that we're going to utilize. 10 to 12. 11, 12. We also have CE to initialize and CSN. Let's set them as output both. That's wrong. 9 as output, and we need to set CSN to high. 9 to high. So this is your initialization for SPI at 8 megahertz on SPI 1 using pins 10, 11, and 12. So now we just need a function to read data or registers. Register. The register to read. The result to send back. Set it to 0. And we need to, before we can read data, we need to bring CSN to low. And then we can say SPI right locking SPI 1, the register, and 1 byte. And then SPI read SPI 1, the no operation byte, and then where we want the result, how many, 1 byte. Set CSN to high and return result. This is wrong. There we go. So now I can use this function here and put it here and let the value dictate the register that is going to be read. So we are going to read 15 registers one at a time from 0 to 14. So we are going to cap value at 14. So 0 to 14 equals 15. And compile, set this ready. So now you're still going to see this scrolling, but the values on the left are not going to be sequential because are the values on the registers 0 to 14, and on the right is the binary representation. So there you go. Now let's make it easier to, or more clear, right? So we're going to read a single register, so let's get rid of this and get rid of this. So we're going to be reading register 0. Let's compile, set this, and let's see what we have. All right, so we have a bunch of ones on the first 4 bits of register 0 are set to 1. So we're going to change them. So we have 1001 instead of all the ones. So we're going to create now the function to write registers, which is, this is the base of, for configuring the NRF, you need to be able to read and be able to write. So write register, the register to write, and the value to write to the register. So pretty much the same thing as this. Just gonna copy this, bring it here, and we're just gonna have 2 of this. Remove that and change this to value. Now the only difference here is that to write a register is required to specify a command. So this is the write register. So what it's telling you is that bit number 5, it starts from 0, so this is 5, 6, and 7, has to be set to 1, and the only bits that you can write are from 0 through 4. Right, so we gotta make sure that that bit is set, and we set a mask so no other bits are sent if they're not allowed. So we're gonna rearrange register, and we're gonna say that only that one can go, right? So 1, 2, 3, 4, and we're gonna mask register to the first 5 bits. So that's 4, 5 bits, and that should do it. So if here before the loop I call write register 0 and we specify 1001, compile, and you are going to see that value change. So instead of 15, it's going to have, what's it, 5? No, 9. There you go. So now you can read and you can write and you can send data. So you are almost there. I'm going to say you're 80% there. So to recap, this is how you initialize UART. This is how you initialize SPI for the NRF. We have a macro to convert an integer to characters. This is for an 8-bit value. And then we have a function here to convert a value into a binary representation of that value. So it takes a value, a buffer, it puts the value. That's a conversion of the value using the macro above and puts it into a string and returns a pointer to that same buffer. And then we have a function to read data from the NRF. Requirements are to bring down CSN. When you're done, to signal you're done, you bring it back to high. Another one to write data to the buffer. Requirements is to have bit number 5 set to high. And only these bits can be set via the value parameter. And same, every time you're interacting with the NRF, you need to bring down CSN. When you're done, you bring it high again. And that is about it. On the next video, we are going to finish creating the functions to properly check to see if there's data waiting, configure it, send data efficiently as well. And that should be probably twice as long as this video, but hopefully not that long. All right, till next time.